Hi everyone, this is Isam. Today I am presenting our work about analysis of thermal bridging in Arabian houses, and it focuses on the residential building in Riyadh area. The presentation goes into introduction, then the aim of the study, after that the methodology used in this study, followed by the result and a discussion and solution, finally a conclusion. Saudi Arabia is experiencing extreme weather conditions with a maximum summer temperature exceed 46 in most parts of the country. Also, it's experienced a rapid population and economic growth the last decade, as shown in Figure 1. This growth leads to a marked increase in demands of electricity. The residential building consumes about 50% of the electricity consumption in Saudi Arabia, as presented in Figure 2. And the villa type covers about 29% of Saudi total housing units, and it covers 45% of total housing units in Riyadh, the capital city of Saudi Arabia. Several studies has indicated that 70% of the electrical energy used in building in Riyadh consumed for air conditioning, as shown in Figure 4. And as you know, a primary and essential function of the building envelope is to enable thermal comfort and protect the building interior from the outdoor climate condition. Therefore, a well-designed envelope should enable a reduction of energy consumption for air conditioning and heating. Thermal bridging due to structural element is clearly shown by thermal image as presented in Figure 5. As you can see, the surface temperature of structural concrete is about 42.6 degrees centigrade and the clay blocks 36.7 degrees centigrade. The study aims to investigate ways to improve building energy conservation by improving the design of the building envelope. It also aims to investigate the compliance of the Saudi Codes 2018. The methodology starts by investigating 8 types of clay blocks. 4 of them are insulated and the other 4 are uninsulated. The best block performance will be used in further investigation. To investigate the impact of thermal bridging, a 3D model analyzed and the U value of this model has used in whole building and energy analysis. As a result, the use of insulated clay block C1 reduced the heat flux by 80% compared to a solid clay blocks. Therefore, it used in the investigation of the impact of thermal bridging. The impact of thermal bridging due to mortar joints and structural elements are shown in Figure 11 and Table 1, and it's clear that the effects of thermal bridging increase the total energy, increase the U value of the building by more than double compared to unbridged building. Also, the effects of thermal bridging increase the total building energy consumption by about 68% compared to unbridged building, as shown in Figure 12. From the results, it should be noted that all the clay blocks by themselves are not comply with the minimum requirements of the Saudi Codes 2018. Also, the best performance insulated clay block C1 exceed the Saudi Code 2018 by about 60%. As a solution for the existing building, it's found that the use of 55 mm external insulation will reduce the U value of the building by about 79% to comply the Saudi Code 2018, and it's clearly shown in figure 13 and table 2. In conclusion, insulated clay blocks design used in Saudi Arabia by themselves do not comply with the minimum requirements of the Saudi Code 2018. And thermal bridging caused by mortar joints and structural elements increase the heat gain by more than double, and the cast concrete are responsible for a majority of the bridging by about 61% compared to the U value of blocks and mortar joints. And as mentioned before, applying 55 millimeter external insulation will reduce the U value by 79% to comply the Saudi Code regulation for Riyadh City. Finally, if you have any question, don't hesitate to contact us. Thank you.